Hey everybody, how's it going? All right, great. The first SauceCon ever. This is super exciting. I will tell you that this is absolutely going to be the best non-keynote talk you have ever heard so far at a SauceCon ever. And I am pretty confident I can maintain that record for 35 minutes until all bets are off at that point, especially because Mike's going to go on. Cool. Anyway, so I'm Jeremy from Codeorg. Super excited to be here, and I'm going to tell the story today of Codeorg and automated testing and our journey and what we've learned. What I'd like to do is start with, I'll give you a little context on Codeorg, tell you a little bit about what it is we get up in the morning to do every day, set the stage, and then we'll go on and geek out about automated testing. Does that sound good? Cool. So one thing that you're probably all aware of is it's hard to hire tech talent these days. I imagine a lot of you guys are working for companies that are trying hard to hire technical talent or having challenges, and it's real. By 2022, there's going to be a shortfall of 1 million computing jobs going unfilled, and that's a really hard gap to cross and has economic consequences. And it's really hard to solve that pipeline problem and close that gap when most schools in the US don't actually teach computer science. About 90% of parents want their kids to have access to computer science education, but most schools actually don't teach it. And we're talking about K through 12 schools specifically here. By one metric, only about 40% of schools do, and that's probably inaccurately high. It appears that a lot of schools answered yes to the question, do you teach computer science? And really what they meant was they teach Word or Excel. So we think the accurate number is somewhere between 25 and 40% of schools in the US actually teach CS. So there is a huge gap to cross to get to where we want to be. There's also a gender gap in tech, and you only need to look around this room to realize how true that is. When you trace back the gender gap from the software workforce back to university and back to K through 12, it's actually identical. To solve the gender gap, we have to work, a lot of different folks have to work from a lot of different angles, and there's many things we have to do to solve this gender gap, but you cannot solve the gender gap without addressing it in K through 12. So that brings us to Codeorg. And Codeorg is a nonprofit tech company, and our mission is to get computer science education into all schools for all students, and specifically to increase participation of women and underrepresented minorities in the tech workforce. At Codeorg, we believe computer science is foundational. It's not just vocational. Computer science is something that every student should have exposure to, no matter what you go on to do in your career. Computer science teaches you so many skills that are relevant today, like breaking down problems into steps, sequencing them together, thinking about inputs and outputs. So we think every student should take at least some computer science to build the skills you need for a whole range of 21st century jobs. Just in the same way we think every student should study math, even though not everyone goes on to be a mathematician. The technology mission at Codeorg is that we're building the software platform that delivers a complete K through 12 computer science curriculum into schools. Now our curriculum and our software, it's used in schools by teachers with their students, which is to say this is not something that is self-directed outside of school. It's not something that replaces a teacher. Our curriculum and our software is integrated into the school and the curriculum and the lesson plan and is a formal part of what gets taught in school. And in our curriculum and our software, we start with block programming as early as kindergarten. My son started doing this exact level when he was 5, and my daughter when she was 3, to keep up with her big brother. My daughter actually became an early reader, so she could keep up and do everything she wanted to do. In fact, my daughter's first 3 words she could read were mom, cat, and random, because random is one of the choices, and she always wanted the sounds to be random or whatever. So that was one of her first words she could recognize because she was using Codeorg. Later on in an academic career, we introduce kids to JavaScript as a programming language. The point is not to produce JavaScript coders specifically, but that's just a good programming language that can teach core concepts and is applicable to lots of other things later on. We also, in our curriculum, don't just teach programming. We also teach other core computer science skills such as compression, cryptography, what is the internet, how do computers work, data, privacy, so a whole bunch of other concepts as well as just programming. We also put on the Hour of Code, and this is a crazy annual event worldwide. We have between 50 and 100 million kids go through this every year, and it is the largest learning event in history. And what we do here is get together as a worldwide community and have kids try coding for an hour. And this goes on in schools, conference rooms, churches, mosques, synagogues, soccer clubs. And the idea is if you can take a kid that hasn't tried coding before and get her to try it for an hour, maybe she'll love it, maybe she'll go further. And usually most kids do go on. In fact, the exciting thing for us is that we do Hour of Code every December, and then by January, when schools come back in, every year there are more schools teaching computer science in the school with sustained activity. So this has the effect of actually driving computer science education into schools, which is our singular mission. So we're super excited to put on Hour of Code every year, and we thank Sauce Labs for being a great supporter of Code.org and our event. And in Hour of Code, we usually have something crazy like a head of state get involved. This past year, we had Justin Trudeau, Prime Minister of Canada, kicked off Hour of Code, coding with some kids in Toronto. You actually can find his app. He wrote an app. You can find it online. If you Google like Justin Trudeau Hour of Code, he wrote a sports app that's a sports game. It's pretty fun. Our tech stack is Ruby on Rails, JavaScript, React. We run on Amazon Web Services. We use MySQL and Ubuntu. We're also on GitHub. We're open source. You can check out all our stuff. I'll be talking about some of the tests later on. You can actually just go on GitHub and look at them. You can look at our pull requests. You can look at my pull requests. You can even look at what's going on today and let me know how the release is going. For sense of scale, we have just shy of 20 million students. We almost 600,000 teachers. We're used in 180 countries. Translated into 45 languages, including Urdu and Kazakh. And we have well over about 500,000 daily users. Goes down in the summer, but that's where we are about now. Some other cool statistics we recently announced is 20% of all students, or all K through 12 students in the US have a Code.org account. So 20% of all students have used Code.org at least once. And internationally, 10% of all K through 12 students in the world have coded on Code.org. So as a 60-person, fairly small company, we're really excited to be able to have this kind of impact and put these kind of numbers up on the board. Also, for a sense of scale, and as it relates to testing, our Hour of Code, which is our crazy annual event every December, goes really big. We run it on the live site we were running on 4,800 cores this past December, and our peak traffic is about 20x higher than usual. And we've had over our 3 hours of code have served hundreds of millions of kids that have gone through it. So in terms of velocity and testing, I think it's always interesting to talk about why it's important to move fast. And the answer is a little different for every organization, and it's good to be introspective about that. For us, some of the reasons we need to move fast are, it's really important for us to be able to iterate and test. We're developing content and technology. We have to pilot in schools. It's not always right on the first try, and we have to keep iterating. So we have to be able to have rapid iteration cycles, take the feedback, and get it out again. We're also really subject to the school calendars. Things happen like to start something new and significant, we really need to start it in the fall as part of a new academic year. Backing up, we have to have that ready to train teachers on over the summer. And then we have certain lockdown dates that just can't move. And we need to be able to iterate and hit those dates, because if we miss them, we've missed our launch window. We also just have a need for continuous improvement. When you look at the scale we're at, how many users we have, and how many schools have taken a dependency on us, we need to be able to respond quickly and make things better, fix problems, and generally improve. And otherwise, we wouldn't be able to succeed at the mission at the scale we're at. So those are the things that we think about why it's important to move fast. In terms of moving fast, we ship every day, sometimes more than once. Actually, it looks like today we're gonna ship in the morning and the afternoon. We have a little thing we need to take care of this morning. I just found out about, and that means manual testing of any sort just isn't a practical option. We just ship so frequently that it would take so many people to do manual testing. We must have a 100% automated solution. So our solution, as I mentioned, is 100% automated testing. Some of that looks like, you can probably guess, well, you need lots of tests, and we do have lots of tests. The other important thing that you learn, which might not be the first thing you think about, is you actually need to parallelize your tests a lot. Because ultimately, you want to complete them in a certain amount of time. You have a lot of tests to get through, so you have to parallelize, and that's been a lot of our journey to figure out how to do that well. So I'll show you what our CI, or continuous integration pipeline, looks like, and the path from a developer writing the code to that code getting in production, and how the testing works. So let's say I'm a software engineer at Codeorg, and I have my cool feature that I've written. I've done this off in a branch in GitHub, and I'm ready to ship it. So I'm going to open a pull request. And a couple parallel tracks of activity happen at this point. So I open a pull request, and it goes gets assigned to one or more other software engineers to look at it and give me feedback on it. Simultaneously, we start running automated tests. This actually happens as soon as I push the branch. And we run our tests. We use Circle CI, and we use that product. It's integrated with GitHub. And we use that as a Linux container to do a pull from GitHub, build a product, and actually run the product, run the server. And then we use Sauce Labs VMs for the browser client to do the automated tests. And we want to run a pretty significant amount of tests. And one of the goals there is they have to complete in about an hour. We don't want it to take longer than that. And so we parallelize to be able to achieve that. From there, if my peer software engineers like the changes, it gets approved by them, and I get a green check mark over there. And if the tests pass, I get a green check mark there. It actually literally shows up in GitHub as 2 green check marks. Once those 2 work streams, I have green lights on them, I proceed and I merge the pull request to our main branch, at which point it's going to go out in the next release. And if anything happens along the way, like if I get feedback from other software engineers I need to change something, or if the tests fail, I rinse and repeat this process. For the production release, this is what happens. We have a main branch in GitHub, and when we're ready to make a release candidate, we merge to the test branch. Now we run a really big automated test matrix. This is even bigger than what we ran in the developer branch. Here, instead of Circle CI, we use Amazon Web Services, which is where we're going to run in production. So we do something that's closer to production. So we have an Amazon Web Services EC2 instance that we pull the code on, build it, run the server. Again, we use Sauce Labs as VM clients to run the browsers on. And we also, in this phase, use Applitools Eyes for visual pixel comparisons. So we have a set of images of known good baselines, and we use Applitools to take screenshots and compare them against the baselines. If something changes, like frequently we'll make changes that affect the visuals, but Applitools will flag that. We'll make sure that any changes are intentional and expected. And again, we parallelize this so it can run in about an hour. And then ultimately those tests pass. And then we merge that test branch to production, and our site deploys automatically from there. The kind of exciting thing about this, or was exciting me when I first experienced, is that most of the time, no human actually looks at the build or tries the build. If the test passes, we get the green light, we know it's good, and we put it out to production. And this is actually my first, when I joined Code.org, this was my first experience with doing it this way, and that took a little bit of getting used to. It's like, wow, you really don't even have to look at it anymore. So the results we've gotten from this are we do a production release almost every business day. We have very few regressions. They happen occasionally, but remarkably few of them, all things considered. And we've done, in the trailing 12 months, over 220 production releases. I'll also mention that when there is a regression, we detect it almost immediately and try to have it fixed within 20 minutes or half an hour. So I think it was Facebook that said, you can move fast and break things, but if you break things, you got to fix things fast. So we also detect and fix things fast. We do, as I mentioned, have lots of tests. I pulled the numbers as of yesterday, and as of yesterday we had over 6,000 unit tests, over 500 browser tests, and 75 visual Applitools tests. And of those 75, they frequently have multiple screenshots within them. This number is constantly changing, generally upward, just depending on what's going on with test writing. As I mentioned, we parallelize because we want to get everything done in about an hour, and we just throw as many resources at it to get stuff done in that hour. For a sense of how much we've had to parallelize, for the developer tests, we're currently running 16 Sauce Lab VMs every time we do a test run on a pull request. We have just under 20 software engineers right now, and they will frequently have 1 to 3 pull requests open. So at 16 Sauce Lab VMs per pull request, we're actually running quite a few Sauce Lab VMs at any one time. I believe we are a pretty substantial Sauce Labs customer. For our production release tests, again, that's an even bigger matrix covering 6 web browsers, iPhone, and iPad. We run over 100 Sauce Labs VMs in parallel in order to get that done in an hour. I will say we run well over 100, and as a team, we like to experiment. We like to experiment with extremes. We have at times had this number be really, really big. I won't put an exact number on it, but we tried some things where we were a little worried that the lights were starting to dim in a data center somewhere. So sorry. We are back in 3-digit territory now. I will say that. But one lesson is don't be shy about parallelizing, because when you run lots of tests, you're going to have to do that. And in terms of what we learned, one of our adventures is we're constantly struggling with test reliability. Our test coverage is pretty good right now. If the tests pass, we're usually in good shape. We don't break a lot of things, but a lot of our pattern is we'll run the tests, most but not all pass. The ones that fail, we rerun until they pass, and then we feel pretty good, but not as good as if they had just passed. And so that's also the thing that's holding us back from where we want to go next. So we're working on test reliability. It's mostly about the browser-based tests, and they just kind of fail for strange reasons. Some of the ways they fail specifically are, well, there's timing, and that means lots of different things or lots of different failure modes, but a lot of the time something will fail once and pass on retry, and we're like, it's a timing thing, and we have to look into it. Right now we're battling with a lot of timeouts and disconnects and 404s, and what this means is basically the browser client thinks the server went away. So you're running your test, you're cruising along, you've pushed 16 different buttons, and you're working through your scenario, and you go to push button 17, and it takes 30 seconds and then times out, or it gives you a 404. And we're still trying to track down what's going on there. We have virtualized environments, talking to virtualized environments, and that's just something we're struggling with and hope to see improve. We run out of memory in VMs sometimes. That's for us more an issue with Circle CI than it is with Sauce Labs. and we're working on just tuning it, seeing what we can fit in, trying to be as aggressive about getting stuff done without running out of memory in the container. And a lot of times the flaky test are just hard to diagnose, and we're trying to build more ways to make it easy for us to figure out what's going on so we can fix it. Some of the specific fixes we've made are, and I actually heard someone else give contrary advice, so you might have to make your own decisions here, is to remove fixed wait times. You can get this pattern where you do something, say I want to wait for 3 seconds, I'm going to examine the DOM and I expect to see this thing changed. The problem is when you're parallelizing heavily, your expectations about how long something will take are not going to be met 100% of the time. So we have been pulling out fixed wait times in favor of synchronizing on something else. And I heard someone this morning say, oh, I love putting in fixed wait times. So figure out what works for you. One thing we did to chase out some problems we had in our tests was we actually deliberately made everything take longer, because you can have problems in your test where you aren't waiting. You can easily write a test where you say, I'm going to push this button, and then I'm going to look in the DOM and see that this thing changed. And the problem is, well, maybe you're not waiting at all, and maybe it's usually pretty fast and you're just lucking out, but then once in a while it's not as fast as you're used to and you don't luck out anymore. So we, at one point, added a 1 second sleep to every response from the server, and that actually flushed out a few places where we had been lucking out and we needed to explicitly synchronize on something to make sure the thing we were waiting for had happened. And sweat the framework details. We discovered at one point we were mixing explicit and implicit weights in Selenium, which you're not supposed to do. And it mostly worked, but not entirely, and is not supported, so we fixed that and got a little step function upward. And also fail fast when you can. It's really easy to write tests that when there's a legitimate failure, it take a while to decide that it failed. You can have tests that will then wait for 30 seconds or 2 minutes before they time out because they're so determined that this thing is going to show up on the web page. And if it's just broken, it's not going to show up. You can wait for a long time for that. We've had things happen where, we had a legitimate failure and it made all the tests take a really long time. So we were sitting there, wow, this test run is taking a really long time today. And then we discovered, okay, it's all because it's completely broken because this button got lost. And wow, we wish we'd known that 45 minutes ago. So we got better at failing fast. I'll show you a little bit about what our tests look like. This is a unit test, so it's a headless business logic test in Ruby. We use some of the libraries we take advantage of include active support for a bunch of the test scaffolding and factory girl for creating test fixture data. And in this fairly simple unit test, this is about courses in script. A course is like a class thing, and scripts are a unit of curriculum within that. And in this test, we create a course, create a couple scripts, put the scripts in the course, load it, and assert a bunch of things about it. And this is pretty typical for a unit test. A lot of ours are longer. This is sort of a short one, so I could fit it on screen. It turns out it sort of seems pretty simple, but you do thousands of these, and asserting everything you can about your core logic, and it turns out it gets you pretty robust. So that's representative of our unit test library. This is an example of one of our UI tests, and we do this in a framework called Cucumber, and this is a programming language called Gherkin. And it is, you notice it's sort of an English language, readable domain-specific language. It also turns out that it's kind of amusing because when you read it, for example, I'll read the last couple lines, and I see no difference, and I close my eyes. It's sort of, especially if you read it in a William Shatner style, it sounds like apocalyptic beat poetry, which is super awesome. So adds a certain je ne sais quoi to your day. Some of what you see here is actually implemented in Ruby, so we get to plug in our own business logic behind it. And as an example, you can see one of our lines here is, as we're setting up the test, it says, given I create an authorized teacher-associated student named Bobby. So the authorized teacher-associated student is a domain-specific thing for us, because we have teachers and students and classes and sections and workshops and things like that. And you want to set up certain scenarios, and we have a bunch of building blocks to let you do that really succinctly in a test. And we have dozens and dozens of these things, so you can set up all kinds of scenarios you want in not that much test code, and then we do all the right things behind the scenes in Ruby. It makes the test really short and makes it really easy to cover all the scenarios you want without a lot of friction. Another thing I'll call out in here, where it says, and I see no difference, that is implemented in the Ruby behind that. We actually call applitools, and this is everything you see about eyes and seeing differences is our test talking to applitools eyes to do visual pixel comparisons against known good baselines. And I think applitools talk is the next talk after in the other room, but you actually shouldn't go to it because you should stay for Mike's talk. But you should stay for Mike's talk and then just yearn for the talk, the other one. And then another example I'll call out here is where it says, I am on this URL. That's a little bit of a passive-aggressive line that navigates you to that URL. And inside that, in the Ruby implementation of I am on this URL, we do a whole bunch of stuff around robustness. Like we will try to navigate to it. We'll try to go there 3 times. We look out for specific errors like bad gateway, and we will flag those. And so a lot of the robustness things that we were struggling with get baked on inside there. But one of the points is that the tests don't have to worry about it. We do it once in the framework. So that's what our UI tests look like. Some of the features in Sauce Labs we really like are the visual log is super useful. If you haven't tried it, it looks a little like this. This is what you see all the steps going on in our test, and we can step through them and see what's going on. And if it weren't for this, we would just have no way to diagnose what was going on with a lot of tests. And so we look at the visual log literally every day. Another feature that we like is using Sauce Labs in manual mode for down-level browsers, of which we have numerous, because browsers we have to support, because schools don't change their browsers very frequently. This is a Slack message that one of our tools sent us. We have a process that monitors our live site and looks out for things that might be browser compat issues. One of our tools looks at levels to see if students are not passing the level in particular browsers. So this was an actual message we got a couple days ago that said, hey, there's been 28 people that have tried level 960 in IE11 and none of them have passed it in the last 2 hours, so you might want to look at it. So if you do want to look at it, there's actually a repro it button right there in the Slack message, and you can, as the person receiving this, you can click on repro it and it actually takes you right into Sauce Labs in IE11, pointed at level 960 in production, so you can hop right in and figure out if there's actually a problem in the down-level browser. And so that's something that is super cool and helps us make sure that we always work for all our students and teachers. One of the ways we pull this off at Codeorg is baked into our culture is the idea that test writing and infrastructure is everyone's responsibility. We actually don't have any dedicated QA people in our company anywhere. It's just one of the engineering functions. And we enforce this in code reviews and also in our culture. And if anybody does go into GitHub, you can actually look at our pull requests, you can look at the conversations that happen there, and you will frequently see somebody say, hey, this looks good, but you actually need more tests. And it's usually not like you don't have any tests. It's like, okay, you've written a couple tests, but you need to actually write a couple more, and here are some of the cases you need to cover. So that's something that we just do frequently. Also mention that this is not necessarily a one-size-fits-all solution. There are organizations where it makes sense to have the QA responsibility be everybody's job. There are organizations where it doesn't make sense, but I'll just offer this as what we do. And to do this, we are always working on test improvements and test quality. One thing we do as a team is every week we have somebody who's in charge of monitoring what's going on with our test stability and reporting back to the team what happened this week. And here's actually the slide. These are literally the slides from last week. We monitor things like how long the tests take, how many times we had to rerun them to succeed, what the trend is week over week. We look at our success rate of test passing in Circle CI. The red here is the failures, but many of those are legitimate failures from tests catching things. We keep track of our 10 most wanted of our flakiest UI tests, and we try and make progress on them every week. So to succeed in the 100% automated test world, you have to expend effort constantly. Our biggest win as we sat down and thought about this over the last year or so was this. It was actually the thing that changed a lot for us was when we started doing really extensive developer testing on each pull request, so basically on each commit. Previously, there had been tests and developers might run them. There weren't a lot of them that the developers would run. And part of it was they would take too long and they would tie up the developer's machine. Really what it was when we added Sauce Labs and Circle CI, which let us run the very extensive set of tests before every commit. And it basically offloaded that load from the developer's machine so the developer can do other things while the tests are running, and also let us parallelize it because you just couldn't run that many tests on your MacBook before you checked in. And what happened was our main branch got really stable. It used to be that we'd come in, we'd be like, okay, we want to ship this today. We'll run the tests in the main branch, and it's broken. And there have been like 30 commits, and you have to go figure out which one of them broke. So this is the thing that really brought us to main branch stability and being able to ship every day with a minimum of drama. We are a web property, and so for anyone that's working on a web property, we talk a lot about quality with automated testing. It's worth pointing out that quality is not just about testing. You want to have fantastic operational tools, which we do. We use these tools. It does mean that if we do have a problem, it shows up either in our telemetry or our user feedback right away, and we do try to fix problems, ideally within half an hour. And so that's, I really feel it goes hand in hand with test automation philosophy. For what we want to do going forward, we want to move toward continuous deployment. We're shipping once a day, but not continuously right now. Where we're at right now, we do 3 test runs a day. The intent is to ship the last one, but we are kind of constantly kicking off test runs if later in the day a legitimate problem gets introduced. We have one of the earlier ones in the can, and we just sync to that commit and ship it. And we deploy about once a day. What we want to get to, our near-term goal is to get up to 10 test runs a day. So that's approaching continuous testing. And then probably deploy multiple times a day to production. We're still trying to decide what we want to do there. But immediately we want to get up to 10 test runs a day. And to be able to do that, we have to fix the flakiness problem I've been talking about. So that's what we're up to. And we want less flaky tests, and we also have to write more tests. Everybody always has to write more tests. These are the amazing people that I get to work with every day that I am super excited to get to call my colleagues. And they actually could be your colleagues too, because we're hiring. It's my job to always say that. Look how photogenic and charismatic they are. Cool. So my prescription is 100% automated testing. If you're not there yet, that's the place to get. As I mentioned, extensively test before every developer commit. That's the thing that was the game changer for us. And the litmus test is you look at how stable your main branch is. If it's not as stable as you want, this is the thing to think about. Lots of testing before every production release. And again, in both cases, you want to parallelize so you can hit the time constraint you want. Make your test reliable. And move fast. And I think you guys know the next line that's coming up. And go change the world. This is what changing the world looks like to us. I hope that all of you have a fantastic vision of what changing the world looks like to you, and you're able to go forward and do it while moving fast. Thanks, guys. It's been awesome.